Hello there. In this class we are going to be focusing on 2's complements. Now whenever you are adding two numbers, in that case you are going to have four situations, four cases. The first case is going to be you are going to have two positive numbers that you want to add. Now as we have studied that complements are only needed when we are dealing with negative numbers, but here there is no side of any negative numbers, both are positive numbers, so we can simply perform the normal binary addition of these numbers. We can convert them into their binary equivalents, and then we can add up and we can find out the result. So we don't need any kind of complement whenever we are performing operation between positive numbers. So we are going to skip this, but I would recommend you to guys to practice this one too, because it will revise your binary addition topics too. Now the second one where we have some interaction with complements is going to be when we are adding a positive number with a negative number, but the positive number is greater than the negative number. This is the second case. Now in this case I've written an example here too. Here the positive number is greater than the negative number. Now in this case what do I need to do? Simply I need to convert this into binary first, then I will convert this 3 into binary. But the trick is you need to find the 2's complement of the negative number. So this is the main point here. What will you need to do? You will write this number as it is, the positive number, but whenever you find a negative number you will simply first convert it into binary, and then you will find the 2's complement of that number, then you will add it with the other number to find out your result. So now here I'm going to convert both of these into their binary equivalents. Now 6 will look like, somehow it will look like this in binary if I have a 5-bit register, and 3 will somehow look like this in binary. But this 3 is not -3, this is the representation of +3. But now I need to find out the 2's complement of this number. So what do I need to do? Now I'm going to tell you a shortcut here. By that you can also find the 2's complement. Normally there are 2 steps to find out this one, but the shortcut is that you will simply start from the right side, which we can say from the least significant bit side, and whenever you find 1, keep that one in front of you, and after that just keep inverting every bit you find. Let's say I found 1 here, now I kept 1 here. After that I'll start inverting them. 1 will be 0 and zeros will be 1. So this can be our 2's complement. So I will write it right here, 1 1 1 0 1. So this is the 2's complement of this number. Simply we can say this is -3 in 2's complement. The positive number, we don't need to find complement of this number. We can rewrite that here too. Now I can do what? I can simply perform addition on these ones by 0 plus 1 will be 1, 1 plus 0 will be 1, 1 plus 1 will be 0. I will have a carry here, 1 plus 1 will be again 0. I will have another carry here, 1 plus 1 will be again 0. I will have another carry here, but this carry will be discarded. Now remember this thing, whenever you are adding a positive number with a negative number, you will always get a left out carry here, and you will always discard this carry. This is a useless thing, and this is the result that you are searching for. Now look, if you will convert this back into decimal, this becomes +3. So I can say that I have verified that my answer is correct. So this is how you add a positive number with a negative number when the positive number is greater than the negative number using 2's complement. The third case is going to be when you are adding a positive number with a negative number, but the negative number is greater this time. So if the negative number is greater, just like here, and the positive number is smaller than the negative number, in this case definitely we will find the 2's complement of the negative number. We will write its equivalent just like that, 0 0 0 1 1, and this number will be also first written like this, 0 0 1 1 0, but then I would need to take 2's complement of this because this is a negative number. So by that shortcut, 0 1 0 1 1. So I can rewrite this number here. This is the 2's complement of this number. I don't need to find out the complement of this number because this is a positive number. I will rewrite it here, 0 0 1 1. Now I can add up these. 1 plus 0 will be 1, 1 plus 1 will be 0. I will have a carry here, 1 plus 0 will be 1, and these two ones will also come down here. So this is the final result here, but you cannot verify just like this. If you want to verify this, you can again take 2's complement of the result, which will be 1 and then 1 0 0 0, which is what, 3. So look, the result also comes minus 3. So this is the equivalent of minus, this is the binary equivalent of minus 3 in 2's complement. So this is how you find out the result when the negative number is greater than the positive number. And the last case is when you have two negative numbers and you need to sum them up. Now in this case we have two negative numbers, so definitely we will take 2's complements of both of the numbers. So first let me write the equivalents of these numbers. These are the binary equivalents of these numbers, as both are negative, so I need to find out the complement of both of them. So the complement of this one will be 0 1 0 1 1, and the complement of this will be 1 0 and 1 1 1. Now I can add them both. 1 plus 0 will be 1, 1 plus 0 will be 1, 1 plus 0 will be 0 plus 1 will be 1, 1 plus 1 will be 0, 1 and 1 will be in the carry here. Now we have, if we have 3 ones and we want to add them up, the result will be 1 and the carry will be 1, which I will again discard in my case too. Again you cannot like understand if whether your result is true or false. You can again find 2's complement of your result to find out whether the answer is correct or not. So if I'll find the 2's complement of this number, 1 will stay on its place. I'll convert or I will invert these numbers. So this will be the 2's complement of the result. Now if I try to convert this back into decimal, this is going to return 9, which is pretty much like it makes sense now. This 9's complement is this, which means this is the minus 9 in our case. So this is how you can perform addition on two numbers using by 2's complements. So I think it's pretty much simple, but there's a problem that mostly arises, which we called overflow, which we are going to be discussing in the next video. We will see that what is overflow and how overflow is arised and why does it arises. So these are the factors that we will discuss in the next video. So keep following us until that. Thank you.